Anagha, and I'm part of the Stat 107 team. And in this video today, we're going to be doing some probability questions involving picking cards out of a deck of cards both with and without replacement. So let's go ahead and get started. So the first question we have here is that we need to draw two cards at random with replacement. What is the chance that the first is a heart and the second is also a heart? So the first thing to notice here is that the question says with replacement. So that means that when I pick a card out of a deck of cards, the first card I pick, I want to put it back right after I picked it. So if I'm replacing the cards and I'm drawing two cards, that means my total will stay the same because every time I pick a card, I'm replacing it. So I'm putting it back. So that means we have a constant total. That means we always have 52 cards in our deck that will not change. Now it's saying what is the chance that the first is a heart and the second is a heart. So I can form my probability statement right now. So the probability that I pick a first card is a heart, and our second card is also a heart. So to do this, I'll have to use our multiplication rule because the multiplication rule describes picking the probability of two events happening, like right after each other. It says, and the second is a heart, so I want to know the probability of the first being a heart and the second being a heart. So the probability that my first card I pick is a heart, well, we know that there's there's 13 hearts in a deck of cards, right? So it's 13 out of 52. The heart is one of the suits that we have in a deck of cards, and there's 13 hearts, 13 spades, 13 clubs, and 13 diamonds. So the first is a heart is going to be 13 out of 52 cards in a deck, and since it's and, I'm going to be multiplying. And the second is also a heart. If we're replacing the cards, that means our total is still 52, and out of the 52 cards in a deck, we still have 13 cards. So my final probability will be 13 out of 52 squared, which you can put in your calculator, 0.0625. So that is my complete answer for the first problem. Now the second problem says, draw two cards at random without replacement. What is the chance that the first is a heart and the second is a heart? So this is almost exactly the same as the previous question, except here, since we're drawing cards without replacement, that means when I pick my first card, I don't put it back in the deck. So after I pick my first card, my total number of cards is now 51 cards because I still have that first card that I picked. I didn't put it back in the deck. So whenever we have problems that don't involve any replacement, that means our total is changing. So that means the number of cards in the deck is actually decreasing because I don't put the card that I picked back in the deck. So again, my probability statement is going to be very similar to the first question. So first is heart, and the second is a heart, except this time it's without replacement. So I know that my total number of cards is actually changing. So the probability that the first card I pick is a heart is still going to be 13 out of 52. I start with a full deck of cards, which has 52 cards in them, and I know 13 of them are hearts. And again, it's and, so I'll be using the multiplication rule. And the probability that the second card is a heart, well, now when I draw the second card, the deck of cards actually only has 51 cards in them because this is without replacement. So again, I didn't put my card back. And assuming that the first card is a heart, the first card should have been a heart, and the second card is also a heart. So that means when I draw my second card, the deck, there's two things going on here. One, the deck has one less card in it, so there's 51 cards. And number two, the deck has one less heart in it because the first card I picked was a heart. So now instead of 13, there's actually only 12 hearts in the deck of cards because again, the first one that I picked was a heart. So for this question, you can type it up in your calculator and you should get 0.05882 as your final answer. And notice the question asks us to include at least 4 significant non-zero digits. So right here, there's the 4 significant non-zero digits in my answer. All right, so moving on to the next question. We are drawing 2 random cards with replacement. So again, similar to the very first question we did, with replacement signifies that there's a constant total no matter how many cards we pick, because each time we pick a card, we're replacing it, so the deck always stays the same. There's always a constant total number of cards in the deck. Now, what is the chance that the first is a king and the second is a king? So here, if we pick 2 cards, we want the first to be king and the second to be a king. So I can write my probability statement here. The first card is a king and the second card is a king. And instead of writing and, I can also use this and. That's also an equivalent symbol here. I'm just choosing to write it out in words. It's the same thing. And here we want to, similar to how we did above, we will multiply the probabilities, right? So it's probability that the first card is a king times the probability that the second card is a king. You can choose to expand it out in this notation. It's the same thing. And now here, the probability that the first card I pick is a king will be 4 out of 52, right? We start with a full deck of cards, and in a full deck of cards, there are 4 kings. Now, since this is with replacement, in my second draw, there's still going to be 52 cards in the deck. And there will still be 4 kings because, again, when I picked my first king, I put it back. So there's still a constant number of kings. Now, if I put this in my calculator, that's the same thing as 4 out of 52 squared, which is 0.005917. And that is my final answer for this question. So now moving on to the next question. Here we're drawing 2 cards without replacement. So again, when I pick the card, I don't put it back. So again, that means my total is actually changing. It's getting 1 less each time I pick a card because I'm keeping it, I'm not putting it back. What is the chance that the first card is a king and the second card is a king? So again, this is a very similar question to the first one, the previous one we did, except it is without replacement. So my probability statement is going to be very similar. And the second card is a king. That's the same thing as saying the probability that the first card is a king times the probability the second card is a king. Now, since this is an example of a without replacement is an example of a dependent event. So that means these two events, the first card is a king and the second card is a king, they're dependent events because when I pick my first card, the total is changing. The total cards in the deck is 51 now instead of 52. So when I write out my probability statement, instead of the second term being the probability that the second card is a king, it's going to be times the probability the second card is a king, given that the first was a king. Because over here, given that I chose a king in my first draw, my total number of cards is less now, so therefore my probability of choosing another king will be different because there will be fewer kings and fewer cards in our total deck of cards. So that's how you know that for without replacement, we have these are dependent events that are occurring. So therefore, my second probability statement will be different because my second event depends on the first event, which was drawing a king. So for these probabilities, the probability that the first card is a king is still going to be 4 out of 52. And the probability that the second card is a king, given the first one you picked was a king, is now out of 51, because again, the first card we picked was a king and it was without replacement. And it would actually be 3 out of 51, because now there's going to be, originally there were 4 kings in our deck, but for my first round, since I picked a king, there are now only 3 kings in our deck of cards. And if you were to put this in your calculator, you would get 0.004525, which would be your final answer. And now this without replacement question is the same as the draw 2 cards at random without replacement. What is the probability that the first is a heart and second is a heart? Again, this is just a more, I guess, expanded out version of the probability statements that we did. Now for this question, this says draw 2 cards at random without replacement. What is the chance of getting no kings? So again, without replacement means that I have a changing total, and we're dealing with events that are not independent, because each round my probability, my total number of cards in the deck changes because I'm not putting them back. So if we're drawing 2 cards, what is the chance of getting no kings? That's the same thing as saying if I have 2 cards, the first card should be any number which is not a king, and the second card should also be any number which is not a king. So out of a whole deck of cards, 4 cards are king, which means 48 cards are not kings, right? So first I'll write my probability statement. So first card is not a king, and second card is not a king. And again, just writing a note here, this symbol means a not, which is the same thing as probably your first card is not a king times the probability that the second card is not a king given the first is not a king. So again, and where am I getting this formula from? It's that the probability of A and B is the probability of A times the probability of B given A. And this is for events that are not independent, which without replacement, again, is not independent. So over here, the probability that my first card is not a king is going to be 48 out of 52. And the probability that my second card is not a king, given my first one was not a king, well, over here, my denominator is a 51. And since my first card I picked out was not a king, that means there are 47 cards in my deck of cards which are not kings. And if I were to solve this on my calculator, I would get the probability of these 2 events occurring is 0.8507. All right, so we have 2 questions left. The second to last question here, we have draw 2 cards at random without replacement. So again, we have a changing total. These events are not independent, so I know that I'll have to use this formula over here. What is the chance of getting at least 1 king? So when we say at least 1 king, that means if I draw 2 cards, that means out of the 2 cards that I draw, I can get 1 king, and the other card can be any, random number, or I can get 2 kings. These are both possible outcomes that can happen that satisfy the fact that, the chance of getting at least 1 king. That's what at least means. At least 1 king out of the 2 cards that I pick. The only event that cannot happen here is the probability of getting no kings. If I chose any 2 cards that were not kings, that is the only probability that, is not part of our of our space here. So when we're calculating this probability, this is the same thing as saying 1 minus the probability of basically getting no kings. Getting no kings. Because remember, the probability of an event happening is the probability of an event, the complement of an event happening, a complement, is the 1 minus the probability of A happening. So we're doing the same thing here. We're saying the probability of getting at least one king is 1 minus basically the probability of getting no kings here. So over here, what I'm going to do is do 1 minus, and the probability of getting no kings, we already calculated that in the previous question, which was 0.8507 right here. And again, this is without replacement. It's going to be 1 minus 0.8507, which is 0.1493. So again here, we just used 1 minus the probability of getting no kings, because when I say getting at least one king, that means I can draw one card that is a king, or I can draw two cards that are kings. I just cannot draw any cards that are not kings. Now our last question is, we have draw two cards without replacement. What is the chance of not getting all kings? So I'm just going to go ahead and erase this. What is the chance of not getting all kings? So again, this is without replacement. So we know, again, these are dependent events here because we have a changing total. And the chance of not getting all kings is the same thing as saying when you draw two cards, you can either pick two numbers that are not kings. You can pick two cards that are not kings. That's all right. You can pick one king, and then the other card could be, anything else. The only thing that cannot happen is picking two kings. That is something that cannot happen here. So you can either pick two cards that are not kings. You can pick one king and one other card. You just cannot pick all kings. That's the same thing as saying not getting all kings. So what we can do here is we can use 1 minus the probability of getting all kings, which is 1 minus the probability that my first card is a king and the probability that my second card is a king, which is 1 minus the probability, this should be the probability that my second card is a king given my first is a king, because again, we're dealing with dependent events. So that means my second event happening, which is the probability that the second card is a king, depends on my first one happening, which was my first card selected was a king, because my total number of cards is changing and the total number of kings is changing. So over here, the probability of drawing a king here is again 4 out of 52, right? There's 4 kings out of 52 cards in a deck. And the probability that the second card is a king, given my first was a king, well, I know that since it's without replacement, my total will change from 52 to 51 cards. And again here, my number of kings will change from 4 to 3 because that first card I picked was a king. And if I were to do this in the calculator and be aware of these parentheses, you want to make sure you do that. You solve for this probability first and then do 1 minus that probability. And that is 1 minus 0.004524, which is the same thing as 0.9955. And that is the probability of not getting all kings. And when you think about it, this probability seems reasonable, right? Because if I select 2 cards in a deck, there's 4 kings. The probability of both cards being king is very low. So the chance of not getting all kings should be very high. So after you do these questions, it's a good idea to, again, look at your answer and see if it makes intuitive sense. If one probability is way too high and you think that, of course, drawing a certain number of cards in a deck of cards shouldn't be that high, then there's a reason to, double check your math or your probability statements. So I hope this video was helpful. And if you have any questions, feel free to leave them down in the comments below. Bye.